Every single day, humanity consumes nearly 2 billion servings of Coca-Cola. Forget the marketing campaigns and the polar bears. The reality of this product is an infernal industrial pace. Modern lines can fill, seal, and inspect over 2,200 cans per minute. To understand this scale, look at the numbers. In a single year, they produce enough bottles to go to the moon and back over 30 times. But if you lined up every bottle made since the beginning, that chain would make the round trip over 2,000 times. Managing this flow isn't just manufacturing. It is a masterpiece of global logistics and chemical engineering. How do you synchronize such speed with perfect precision? Welcome to the machine. Today, we are dismantling the process to show you how the world's most famous liquid is really made. But before we fire up these modern machines, we have to look at the source code, 1886, Atlanta. A pharmacist named John Pemberton is not trying to build a soda empire. He is concocting a chemical solution for headaches. 2 years later, dying and broke, Pemberton sells his formula to Asa Candler for just $2,300. Candler didn't just buy a recipe, he bought the seeds of a global superpower. Today, that original sheet of paper is considered the most guarded trade secret in American commerce. Locked in a high-security vault in Atlanta, it is protected by biometrics and armed guards. Industrial mythology claims that only 2 anonymous executives know the full formula at any given time. And they are never allowed to travel on the same plane. True or false? It doesn't matter. Because a secret recipe is useless unless you have a vessel to put it in. Before we can mix a single drop of soda, we need a vessel capable of holding it. Most people assume bottles arrive at the factory fully formed. They don't. Shipping empty bottles means shipping air, which is a logistical nightmare. Instead, the factory receives preforms. They look like small, thick test tubes made of PET plastic. They are tiny, hard, and unyielding. To transform this tube into the iconic bottle, it enters the blow molder. First, the preform is heated to exactly 115 degrees Celsius. This softens the plastic just enough to make it elastic without melting it. Then, the magic happens. A stretch rod pushes down to extend the length, while high-pressure air, up to 40 bars, blasts inside. In less than 1/10 of a second, the tiny tube expands to 15 times its original volume. The mold walls are water-cooled to instantly freeze the plastic in its new shape. This violent expansion happens at a rate of 50,000 bottles per hour. For cans, the process is metallurgical. They start as massive coils of aluminum sheeting weighing several tons. A press punches out a simple cup, which is then stretched thin through a process called ironing. The most critical step is necking. The top of the can is squeezed in slightly to accommodate the smaller lid. If this metal is even a micron too thin, it will buckle under the pressure of the carbonation later. Now that we have the container, we need the liquid. It all starts with water, which makes up 90% of the product. But local municipal water has a specific taste that changes from city to city. For Coke, the taste must be identical in New York, Paris, or Tokyo. So the water undergoes polishing. It passes through sand filters, activated carbon, and finally, reverse osmosis. The water is stripped of every mineral and impurity, creating a perfect chemical blank canvas ready for the recipe. Next comes the energy. Massive tanker trucks arrive daily, pumping liquid sugar or high fructose corn syrup around the clock. The facility's pipes are often heat traced to keep the sugar from crystallizing and clogging the arteries of the plant. This sugar is mixed with the purified water and pasteurized at 85 degrees Celsius to create simple syrup. Then the secret arrives. In sealed steel drums, the factory receives the concentrate. Manufactured in high-security plants, this contains the 7X formula, a blend of citrus oils, vanilla, cinnamon, and other extracts. When this concentrate hits the simple syrup, we get the final syrup. It is dense, black, and aromatic, but right now, it is completely flat and undrinkable. To turn this syrup into a soda, we need physics. The syrup is mixed with water at a 1:5 ratio, but here is the critical rule. Carbon dioxide loves the cold. You cannot carbonate a warm liquid. It would explode in foam. The mixture passes through a carbo-cooler, dropping the temperature to a frigid 2 degrees Celsius. Under high pressure, CO2 is injected and dissolves into the liquid. Meanwhile, the empty cans are blasted with ionized air to remove any microscopic dust. They are now clinically clean and ready for the main event. They enter the heart of the factory, the Rotary Filler. This is a masterpiece of engineering. To fill a can at this speed without creating a foam volcano, they use isobaric filling. The machine first pressurizes the can with CO2 to match the tank's pressure. Gravity allows the liquid to flow gently down the walls of the can. It's a violent process, executed with surgical delicacy. Instantaneously, the lid is applied. A double seamer mechanically folds the metal lid onto the body in a fraction of a second, creating a hermetic seal. Production is one thing, consistency is another. Every 30 minutes, bottles are pulled off the line and taken to the quality assurance lab. Here, scientists use a refractometer to measure the Brix level, the precise ratio of sugar to water. If the Brix is off by even 0.1%, the entire batch could be scrapped. They also test the torque. Too loose, the gas escapes. Too tight, you can't open it. It's a delicate balance, but the most intense test is the stress crack analysis. Bottles are pressurized way beyond normal limits to ensure that if you drop your Coke on a hot summer day, it won't turn into a grenade. Back on the line, the filled cans enter a tunnel warmer. We chilled them to get the bubbles in. Now we must warm them up to room temperature to prevent condensation. Wet cans create mold in cardboard boxes. Dry cans do not. Once dry, a high-speed laser etches the production code. This is the bottle's birth certificate, allowing the factory to trace it back to the specific minute it was made. Finally, the robotic ballet begins. Automated arms stack cases onto pallets, and laser-guided vehicles navigate the warehouse floor, sometimes in total darkness, moving tons of product with the grace of a figure skater. From raw water to a finished pallet, the process takes less than 48 hours. So the next time you hear that satisfying pshh, remember, you aren't just drinking sugar and water. You are tasting a marvel of modern engineering. If you enjoyed this dive into industrial secrets, hit subscribe.